Hello there. This is just a bite-sized peek into our comprehensive back-end development course, and I'm all about sharing snippets like this on our YouTube free of charge, so sit back and enjoy the video. But if you're interested in diving deeper, why not consider a Covalence community membership for just $25 a month? It's your golden ticket to a full-stack learning experience, curating all of these videos into a comprehensive course, complete with lecture notes, reference sheets, and challenging labs that are really going to push your learning into overdrive. But the perks don't end there. You're going to unlock the keys to our front end and our React, or my React course as well. Not to mention you're going to have access to live Discord support, meaning you can harass me all you want, exclusive coding events, plus professional assistance for crafting killer portfolios and resumes. Just think of it as your personal coding toolkit, ready and waiting to help you build your future. So check the description down below for a link, and remember, whether you're here for a casual browse or a deep dive, just enjoy the video. Okay, my intrepid students, we're picking up from the last walkthrough by learning, finally, the last thing you should prepare for before I actually let you loose onto your own projects, which is SQL injection attacks, or how to properly placeholder and parameterize your queries so you don't blow yourself up and cause a massive issue on your code bases. You don't want me, Andrew, or any other instructor aggregating or dropping data from your database because you gave us access to it via a parameter in a simple URL, for example. So what does that all mean? Why is this important? So let's actually cover what it is, some interesting facts about it, and some use case and some history behind it so I can show y'all why we need to learn this. Okay, so SQL injection attacks. It is a type of cybersecurity vulnerability where an attacker manipulates user input to inject malicious SQL code into a database query. Cool, that's the textbook definition, right? By doing so, the attacker can gain unauthorized access to the database, read sensitive data. This is typically what happens in the real world, a breach of information, getting information from a user's table, modifying data, or even deleting data if they're particularly annoying. That's what Andrew and I would do. We would probably just delete your data or drop the tables and mess up your entire project. That's the worst we could do, right? In the real world, you could lose an entire list of emails and passwords. God forbid you actually store them in plain text. You would lose millions of potential clients worth of data if someone discovered there's a SQL injection vulnerability on your server and database combo. And that's actually what happened in several instances throughout history. I mean, this is not an uncommon problem, unfortunately, as simple as it happens to be to solve. Now, back then, probably a little bit different than how simple it is today, since it's baked into the MySQL and MySQL2 and most driving libraries, for example, and ORMs for that matter. So SQL injection attacks occur when web applications do not properly validate, sanitize, or handle user input. Remember, if you have any kind of user input, a form on a web page that sends it as a URL encoded parameter or via a request body, for example, that information sent by a user, we can just, if we don't check it first or validate it somehow, it is a good idea to assume that we can have a malicious value sent to us to test the waters. So again, you got to sanitize your database user inputs, which we'll talk about that meme here in a second. So there is a relevant comic to all this. If you ever hear the legend of Bobby Tables, this is an XKCD comic that Andrew and I and most people on our Discord already recognize and know because of how often we throw it out. Hi, this is your son's school. We're having some computer trouble. Oh dear, did he break something? In a way. Did you really name your son Robert parentheses or quotation mark closing parentheses semicolon drop table students semicolon minus minus? Oh yes, little Bobby Tables we call him. Well, we've lost this year's student records. I hope you're happy, and I hope you learn to sanitize your database inputs. Ooh, realize my head's in the way. Yeah, so if you just look up Bobby Tables, this will always be the comic that pops up. And again, it's the example of if they really name their son this value and they input it into a form on their web page, right? Like an administrator or assistant or secretary or somebody would just input this information of a user's name into a student name, first name field, for example, and then this would get added to the insert statement, for example, and it would drop the students table should it be a SQL database of some kind, right? And that is telling them that you need to sanitize your inputs to make sure something like this isn't directly sent into a query, right? So let's actually take a look at what that looks like. So I don't have this project running at the moment from the last walkthrough, but I haven't changed any code. So what we're going to do is head to our routes file, into our users.ts file. And what I want to do is console log our request params.id. This ID value I told y'all that didn't matter in that previous video. This is why, because I wanted to show y'all this before I send it into the get1 function. So let's console log that value and go back to our project and start running it really quick. You can see I did some tests between the videos here. There we go. I'm going to run a curl to, I don't need the I, who cares about that at the moment. Nope, API users, that's what it was. So let's hit our API users 123 endpoint, and there's that 123 console log we see right there. That's what I would expect to see when I add the parameter of 123. That's what rec.params.id takes place. Now, I went to Google and looked up a URL encoder, urlencoder.org, and look what I've done here. Let's actually do 123. There we go. So 123 semicolon drop table users. Okay. This right here is a SQL injection attack. I'm going to take this, realizing that there is a parameter, a ID parameter on a server endpoint, and I'm going to see if I can inject some custom SQL into this parameter to see if this function is going to run it. At the moment, I don't have to worry about it because I've hard-coded the parameter of 1 directly inside the get1 function. But what if this is the parameter I tried to use? We're going to go down from urlencoder.org, write in the SQL injection attack I want to try. I'm going to write encode, or click on the encode button. I'm going to take this encoded value, and I'm going to paste it in my curl request at the end in place of 123. So I took a semicolon, drop space, table space, users semicolon, and I encoded it to make sure it was URL friendly. Watch the console log underneath 123 after I hit enter correctly down here. Well, I probably don't want to paste that into my query because that would be a terrible idea. So this is what it means by sanitize your database inputs, people. If I or any malicious user realize there's a way to send a parameter to a query, this is a SQL injection attack. I have injected malicious SQL into that ID that if you simply string concatenate it into this value, so what if I passed in the ID? What if I did this? Const ID equals rec.params.id. Pass in the ID to the get1. At the moment, it's not going to be happy with what it is. Let's go and change that into DB, into users.ts. This will take a new parameter called ID, which will be a string or a number. We'll get into one or the other here in just a moment. At the moment, all parameters are parsed as strings by default. So that's something else to keep in mind. So what happens now, if this is my parameter and I simply concatenate it on the ID, for example, like what if I'm like, oh, okay, I can concatenate on my ID and call it a day, and that's what my query is going to be. Now, I actually don't want to run this. I just realized I don't actually want to run this. Oh, no. Okay, let's paste it there. And then let's go back to what it was so I don't destroy my own code base by mistake here. I'm hoping that MySQL2 is smart enough to not allow that, but I'm not going to risk it. Let's see what this console log looks like when I simply concatenate the ID on here. If you ever encounter anything that's showing you how to do this by concatenating a parameter that the user has access to directly on your query, abandon that YouTube tutorial, that Udemy course, or that blog post that you're reading, because this is bad news, folks. You do not want to do this. Okay, let's rerun the project. And let's recurl this information. This would be terrible. I would select the one user's ID, and then I would immediately drop table users. Because remember, the placement of the semicolons will dictate where one statement stops and the next begins. And this is valid SQL. If I copied this and pasted it and ran it in my workbench, it would select the one user. It wouldn't find 1 by 1, 2, 3, and then it would drop the users table. This is where a select email password from users table could aggregate or enumerate some information about our user. This is where a security breach could happen, which is what happened in 2008 on the, Heartland, I believe. Heartland Payment Systems, a major payment processor, experienced a significant data breach in 2008. Attackers used SQL injection to inject malicious code into the company's payment processing system, compromising over 100 million credit card and debit card transactions. So 2008 Heartland, again, it resulted from a SQL injection attack, something that we know is fairly simple to account for. It's not that, back then it was a different beast, but these days it's simple to account for and known as bad. We also had the other one, which was the SPN or Sony PlayStation Network, PSN rather. The Sony PlayStation Network breach in 2011. The Sony PlayStation Network suffered a massive data breach due to a SQL injection attack. Attackers exploited a vulnerability in a web application to gain unauthorized access to user data, leading to the exposure of millions of users' personal information. And again, the LulzSec, that old Twitter account, anonymous splinter group claimed that this was a simple break-in tool, a SQL injection, because we know it is, to get into Sony's servers and get a millions of users worth of information they could sell on the black web or things like that. So, yeah, these are not uncommon. I'm assuming they still happen even in today. I just wanted to bring up the two most high-profile ones, for example, if you want to look into yourselves. Hit me up in the Gravity down below or in our Discord channel. Let me know if there's any other major ones you've come across going, I've heard about these, actually, because you'd be surprised. Yeah, so that's SQL injection attacks in a nutshell and why we don't want to do them. So let's instead figure out how we want to properly parameterize and escape user inputs and actually sanitize and validate them. Again, because this is a common thing, thank goodness the MySQL2 library has this feature built in. So does the MySQL library for Node. So again, MySQL2 and MySQL have this built in. You could go and check the documentation for how to handle it. I'm going to show you the simplest way to do so. Okay, so we need to talk about question marks. And by that, I mean, what does this mean, right? Because this is how you do that. The question mark is a placeholder. The question mark is used in parameterized queries or prepared statements, right? It indicates that a parameter will be passed to the query and the actual value of the parameter will be provided separately. So just like our functions in JavaScript have parameters we could pass to them to customize their output, for example, the same thing can happen into queries using the MySQL and MySQL2 Node libraries. And I imagine most drivers use this pattern here. So, and by driver, I mean like the library that connects Node to our database, whether that's Postgres or MongoDB or something like that. The question mark is a parameter we're passing to our query that we're going to make sure is sanitized and validated before it is placed and executed into the query itself. Parameterized queries separate the SQL logic from the user input, making it more secure in preventing SQL injection attacks. So how does the MySQL2 library handle this? It's designed to handle these, and when we pass a query string with placeholders and an array of parameter values to the pool execute method, or similar methods like pool.query, the MySQL2 library takes care of properly escaping and formatting the parameter values. By using these prepared statements, the library ensures that the user input is treated as data, not executable SQL code, thus preventing SQL injection attacks. So it's going to make sure that the data that we are escaping with this parameter, it's going, oh, is this just data or is this SQL code? If it's SQL code, we ain't going to run because that's an injection attack. If this is just data that's properly formatted, we good to go, bro. That's fine, man. No problem at all. So the library communicates with the MySQL database server using the MySQL protocol, which was established in our pool connection. And it sends the query along with the parameters separately, right? Keeping them distinct and secure during the process. Using parameterized queries is a best practice to defend against SQL injection attacks and is strongly recommended for any application that interacts with a database. So again, this is why I'm not cutting y'all loose until we cover this walkthrough here. Or prepared statements to protect your application from potential security risks. We saw that is a huge breach if we have something as simple as an injection attack get us like that. So how do we actually format and get everything up to code, so to speak? So I showed y'all that this escape property is what we're going to be using. And here is how it's going to get added over to our code. Oh, where did I put it? Okay, we're going to keep it simple here because I don't want to overdo it. Meaning, we're going to head to our query utils. This is where we're going to be using this code here. What I want to do is pass to pool execute any escape parameters. They're going to be done as such. It is nothing more than a secondary argument to the pool execute. In place of these triple question marks, the second parameter, this is where our escaped parameters are going to be added. So they get sent to again, with the MySQL protocol, sent to our database as two separate entities, a query string with escape placeholders, and some parameters that will be confirmed as not SQL code. Once that data is confirmed, it then combines them into the one query, the database runs it, and sends us back the information. So how do we do that? What if we just say, I'm going to pass in a list of params that are going to be sent to pool.execute. So some parameters, that's it. What is their type going to be? Let's just do it this way for now. I'm going to say params, which are optional. There are some queries that may not take parameters, so we're going to make them an optional property done by the question mark operator in TypeScript. This is a TypeScript feature at the moment only, not a JavaScript feature for making optional function parameters or arguments. And it's going to be, for now, an any array, because it needs to be an array of values we intend to escape, because we might have multiple question marks in a query. Select star from users where ID equals X and name equals Y. Maybe we were looking for a where and clause. We're finding two values in two columns, for example. That would be two separate question marks, and you'd pass them as an array of escaped values. The array values match the order of our question marks, which I'll show you all here in just a second. So we're going to do an any array because that can be strings, they can be numbers, or they can be even objects or even other arrays. Rather than account for all that crazy stuff, I'm going to take the easy way out, and we're going to write any array of, like, an array of any kind of values, because again, that will depend on the type of query you have. An update and insert query might have a lot of question marks, for example. Insert ID, name, email, password, question mark, question mark, question mark, question mark type deal. It might be update users set ID equals name equals question mark, ID equals question mark, name equals question mark, email equals question mark, and then the parameters would be ID, name, email. So again, it needs to be an array that matches up with the order of the question marks our queries are going to have. So this is the modifications we have to make to select and modify queries. Optional arguments that we can pass in when needed that will be an array of any kind of value and simply added to our execute function code. That's it. That's the only thing we have to do in our utilities. Now, back in users DB, this question mark right here is not quite enough to get this query done. So what we're going to do is pass a secondary arg that'll be an array with the ID property inside of it. So this question mark now is the first question mark we see in our query string, and the first value in our array must be the ID that we're passing in. So if we had an and clause that was also looking for somebody's email address, it'd be a second question mark, it'd be a second parameter, and then the email is the second question mark. So inside this array, email must be index 1, or the second element inside of there, in order to match up with the order of question marks. So the first question mark corresponds to the ID, the second one corresponds to the email, and that order here is important. But remember, the order in our parameters is not important, right? So I could have it written this way, and as long as the order of my question marks and my array values match, so these two must match together, their order is very important. This order is not important. I want to point that out because I see a lot of students thinking that the order of the parameters has to match the order of the question marks, must match the order of the array values. Not the case. But nevertheless, I wanted to point that out. But there we go. That's what it looks like. So that's what our escape value looks like. Some students like to do things this way too. They might have const query string equals this. Oh yeah, I could just cut and paste, couldn't I? Paste, paste, paste. That way the call of the function is a bit easier. They like to keep the query string as its own variable right above it, for especially when you start adding more join statements and things like that, and column aliasing and whatnot. It might get cleaner and easier to use even backticks, because backticks in a string literal, template literal, allow you to actually do new lines. So I've seen my students also do the following, where they change it to backticks like that, which does allow them to write new lines, so they can actually write like a formatted query of some kind if they wanted to. You don't need to do this, but again, the backticks allow you to do new lines like that. So if you have more complex queries and it helps you understand what you're looking at, that's totally fine, which is why I have some students do it that way. But for this simplicity, we're going to keep it to regular quote strings right there. And this is what our call to select query get one's now going to look like. And nothing's going to change up here in select query get all, right? So here we go. Does it work? Let's go find out. Back in our users routes file, we're going to pass in that parameter ID right there, and we should be good to go. Let's go ahead and give it a shot by stopping and restarting my project. And then doing a curl to user123. Now, we don't have a user123 in the database, so what do we get? We get nothing because we got no user right there. So we need to maybe think about including some kind of backup case where a query runs successfully but returns no results. Now, if I go to user ID 1, boom, we get Mario. 2 should be Luigi. We get Luigi. So now we have our parameter ready to go. And it is also coded to not accept SQL code. Righto. So yeah, that is how you properly escape parameters and use the question mark placeholders to make sure that we are not SQL injected. We can test this finally by going up to our old query, which was our good friend drop tables. And I changed it from 1, 2. We're going to change it from 1, 2, 3 to just 1. Hold on. I think I messed something up. Let's go back to the query URL encoder. Yeah, I'm going to take user 1. Oh, let's do it this way. We know user 1 is Mario, so I'm going to do user 1 drop table users. That's my SQL injection I'm going to try and do, which, with any luck, this is not going to work. In my curl http://localhost:3000/API/users/user1 drop table users, the parameterized part should capture the one part successfully and not allow the drop tables to work. I'm going to laugh. I'm going to laugh so hard if this does not work. Okay, it got us the Mario, which is correct. The question is, did it nuke the database? Let's go over to my database over here. I'm going to open MySQL Workbench. I have it open already, so if y'all need to open it and test it yourselves, go for it. But select star from users, and nothing got dropped. So the malicious code was not executed because we escaped it properly, and then the MySQL protocol parameterized it and sent it over to the database. The database is like, this is SQL code. I'm not running that. I'm just taking the value itself. And voila! We have prevented ourselves from destroying a database or selecting all users and populating data that we don't need to populate. Other things we could take into consideration would be knowing that our parameters are not necessarily required to be strings, but they are ID values. I could change this to like user ID for a more proper name like that, for example. And what I could do is I could take this code and pass it into parse int with a second arg of 10. This makes sure that it is parsed to an integer, a whole integer only. It ensures the ID is an integer. So this is another little sanitization test we can do on our value. Now I need to go back to my get1 function, which is db users, and change it from string to number, which will now make it happy. So I parse it from a string to a number, ensuring it winds up with a integer value, and then that ID right there goes in. So that means if I restart the server, we have yet another thing in front of that curl that could make sure that it doesn't nuke itself. So there's npm run dev. There is the bad code, right? That seems to work just fine still, oddly enough. And if I go and remove it all and just do user ID 1, we get Mario. 2 should still be Luigi. There we go. So all of our code is still running nice and correctly, which is pretty cool. So yeah. There y'all go. There's some cool things to know about SQL injection attacks and how placeholders can help us. So there is one more thing with the placeholders I want to show y'all. And you know what? I said this is going to be one of the last walkthroughs, but I want y'all being prepared. I don't want y'all having any kind of doubts about how this code works. So I'm going to show y'all some extreme shorthands that you can do with this question mark to really kick it up a notch with your SQL code here. So I'll see y'all in the next walkthrough where we talk about some final shortcuts you can do with question marks in your parameters.